Hi, I am Syed on Maths Online.
Today, let us take the topic on Laplace transform of periodic function. In the previous video, we have solved a few problems based on periodic function. We'll try to continue with few more problems on periodic function. Let's start the next example.
Next question is show that Laplace transform of f of t is equals to e by s times tan h as by 4. Given the function f of t where the value of t, f of t is e, the value of t lies between 0 to a by 2, and f of t will be minus of a when the value of t lies between a by 2 to a, where the value of f of t plus a is equals to f of t. So this condition that is given represents the periodic function. So therefore, if you write down the period in this case, the period in this case will be this f of t plus capital T. So capital T value is a. So the period over here is a. So for periodic function, we know the Laplace transform. Laplace transform of f of t will be equals to, it is 1 by 1 minus e power of minus of st. Integral value will be 0 to t. It is e power of minus of st f of t into dt. So if you plug in the value of capital T to be a, so you'll be getting 1 by 1 minus e power of, it becomes minus, I'll just rewrite this as a into s, where small a is nothing but your capital T value. It is integral of 0 to, so t value is a, so e power of minus st f of t into dt. But f of t is defined for the interval 0 to a by 2 and a by 2 to a, so I need to rewrite the integral. So if you try to rewrite the integral, I will be getting the expression to be equals to 1 by 1 minus e power of minus of as. So I will try to rewrite integral 0 to a by 2. Integral 0 to a by 2, it is e power of minus of st. So try to observe for 0 to a by 2, what is the value of f of t? So the value of f of t is capital E. So capital E times of dt, plus again integral is from a by 2 to a, e power of minus of st, and f of t value for a by 2 to a is minus of e times of dt. So let's try to integrate this one. It is 1 by 1 minus e power of minus of as. Here e is a constant, I can take that e outside. So we'll be just left out with e power of minus st into dt. So you can integrate this one. E power of minus st will be e power of minus st divided by minus of s. And the limit values in this case are 0 to a by 2. Coming to the next term minus e I can take common outside, and once again integrate e power of minus st. E power of minus st will be e power of minus st by minus of s. Limit values will be from a by 2 to a. So let's further simplify this by applying the limits. This will be equals to 1 by 1 minus e power of minus of as. Minus e by s, you can take common outside. Upper limit value will be a by 2. So e power of minus of t value is a by 2. So as by 2 will be getting as by 2 upper limit value, minus e power of lower limit value for t will be 0. So we'll just be getting e power of 0. Next term minus of minus will become plus e by s, I'll write outside. Apply the upper limit value for t as a, so we'll be getting e power of minus of as, minus the lower limit value for t will be a by s, so we'll be getting minus as by 2. Further simplify this one. This will be equals to, it is 1 by 1 minus e power of minus of as, which will be equals to, just multiply it. So you have e e power of minus as by 2 whole divided by s, and minus of minus, next term will become 0, e power of 0 is 1, you'll just be getting e by s. Next term plus you have e power of minus of as divided by s. Next term will be plus into minus will be minus, it is e power of minus as by 2 whole divided by s. So we'll just try to simplify this expression over here. So if you try to simplify the expression, in this case, further in all the terms you can see e by s is common, so I'll be taking e by s common. So e by s times of 1 minus e power of minus of as. So try to simplify this expression. You are left out with minus e power of minus as by 2. So here plus 1 is left out. Here plus e power of minus of as is left out. It is minus e power of minus as by 2. So these two terms you can see over here are the same. You can just this will be equals to, it is e by s times of 1 minus e power of minus of as. I'll first write 1 minus of e power of minus as by 2 minus of e power of minus as by 2 will be minus 2 times of e power of minus as by 2. One more term, that is e power of minus as will be as it is. E power of minus of as as it is. If you try to observe this expression, this is in the form of a minus of b whole square form. So how can we say that it is in the form of a minus of b whole square form? So a square will be 1 minus 2 times of a value will be 1 into b value, that is if you want to get the same expression, I'll just write it as e power of minus as by 2. Alright, so this has become a square minus of 2ab plus, I have to write b square. So in this case b is this expression. So e power of minus of as by 2 whole square. So is it not in the form of a square minus 2ab plus b square? So here this 2 and 2 will get cancelled and you will be getting back this value of e power of minus as. So can I write this expression as a minus of ba is 1 minus b value is e power of minus as by 2. So a minus of b whole square. So this whole expression can be written in that form. So if you try to rewrite this, it becomes e times of 1 minus e power of minus of as by 2, it is whole square, it is whole divided by s times of 1 minus e power of minus of as. So this problem has been further reduced in the form as we have done in the previous example. So here also you have to get the standard expression. So to get the standard expression, I can rewrite this value to be equals to, that is e times of 1 minus e power of minus as by 2 whole square you have. So because in the numerator you are having e power as as by 2, denominator also you can try to get the same power. So can I rewrite this as 1 minus e power of, can I write this as as by 2 whole square, just multiplying and dividing by 2. So is it not in the form of a square minus b square? So a square minus b square will be a minus b into a plus b. So e times of 1 minus e power of minus as by 2 whole square, it is whole divided by s times of a minus of b. So 1 minus e power of minus as by 2, as by 2 into a minus of b and a plus b, 1 plus e power of minus as by 2. So if you try to observe in the numerator and denominator, the values will cancel out. So this 1 minus e power of minus as will cancel out once with the numerator value, 1 minus e power of minus as by 2. So you'll be left out with e times of 1 minus e power of, once this value will be left out in the numerator, whole divided by the denominator you have s into, it is 1 plus e power of minus as by 2. So once again, if you want to get in the standard form, I just try to multiply and divide. Multiply and divide by e power of minus half. Suppose if I add the expression to be plus 1 by 4 to get a uniform value in the numerator as well as in the denominator, so that we get cos hyperbolic function as well as sine hyperbolic function. So if I take the LCM as 4 over here, you will be getting minus of 2 plus 1, so which is nothing but minus 1 by 4. So for the first term minus half, you have to add 1 by 4, so it should be as by 4. So 1 by 4 times of as. So this will be equals to, it is e by s. I'll take this as common outside and see what will be left out. So I will be multiplying this by e power of as by 4. So e power of as by 4 minus. So what is happening over here? So e power of minus half times of as by minus half times of as, and I'm multiplying that by plus 1 by 4 times of as. You will be ending up with minus 1 by 4 times of as. So minus 1 by 4 times of as, will be getting minus as by 4. So to get a uniform value as by 4, you have to multiply and divide by e power of as by 4. Denominator also, I will multiply that by e power of as by 4. So e power of as by 4 plus e power of, same thing will be getting, it is minus of as by 4. So further, if you try to simplify, it is e by s. The numerator value will be 2 times of sine h times of as by 4 you get. The denominator value will be 2 times of cos h. It is as by 4. To get this expression, I have multiplied and divided by e power of as by 4. So this 2 and 2 will cancel out. So you will be getting the expression to be equals to e by s. So sine by cos will be tan hyperbolic function of as by 4. So that was the result that I wanted to show. Hence we got this particular solution. Let us move on to the next question. The next question is, if f of t is equals to t for the interval 0 to a, and f of t is equals to 2a minus of t for the interval t lying between a to 2a, and f of t plus 2a is equals to f of t, which means that it is a periodic function, you have to sketch the graph of the function, and we should also show that the Laplace transform of f of t is nothing but 1 by s square tan h as by 2. So let us start the solution. We'll first try to sketch the graph. So there are two values that are given in the, so the first value that is given is f of t is equals to t. So I need to draw the graph for this one. So let us take the value of f of t to be equals to y. Right, and we know that f of t is what value? F of t is t. So I will be taking y is equals to t to draw the graph just for convenience. So I have got y value to be t. So what does this y is equals to t represents? Y is equals to t actually represents a straight line. Just how you write y is equals to x, it represents a straight line passing through the origin, making an angle of 45 degree with the x-axis. So instead of x-axis, in this case you are having the t-axis. So if I try to draw the graph, so 45 degree, so this is the graph that you will be getting. Y is equals to t. So this represents your t-axis. In place of x-axis you are having t-axis, and this represents your y-axis. Alright, this represents your y-axis. So therefore I have got a straight line y is equals to t. In the same way, you have the second function f of t to be equals to 2a minus of t, but I have taken f of t to be y, so y will be equals to 2a minus of t. Or further, if I try to simplify this expression over here, y, I'll take this minus t on the other side, becomes plus t, y plus t will be equals to 2a. Or if I divide the entire expression by 2a, so you'll be getting y by 2a plus t by 2a is equals to 2a by 2a will be 1. So this actually can be written in the form of, say, t by 2a. Just for convenience, I'll first write t by 2a plus it is y by 2a is equals to 1. So this equation represents the intercept form of equation, which is similar to the equation in the form of x by a plus y by b is equals to 1, where this a is an x-intercept and b is the y-intercept. So here a and b in this case both are 2a itself. So if I want to plot the graph, so I need to get the x and y intercept. A value in this case is 2a, b value is also 2a. So a corresponds to your x-axis, but here your x-axis is t-axis. So on the x-axis you have to get 2a. So what I have plotted over here in this case, so if I just try to take this particular value over here, so y is equals to t, it represents the straight line passing through the origin I have taken. Suppose if I am taking this to be equals to the scale as a, so this scale that you have taken here, so it is x is equals to a. So somewhere over here, if I am taking that value to be 2a and then say 3a over here, the scale you can take, it is 4a. Alright, it is say 5a, and over here as say 6a, that is the scale. So here also this is origin, this is a. Suppose I am taking this scale to be equals to say 2a over here. So your, what is your x-intercept or t-intercept? T-intercept is over here. So this is one point you have. Another point, it is y-intercept. Y-intercept is, this is 2a. So I need to just draw the straight line over here. So if I draw the straight line over here, I was not exact over here, I'll just draw it. So just a straight line passing through this 2a. Okay, passing this 2a. It's not exact, you can just use the scale and draw it. So exactly it will meet over here. So a and 2a, it will meet over here. However, I'll just try to erase the above line to just get the scale. So I'll just try to erase this one. Alright, so you can see you have got one cycle 0 to 2a. So in the same way, if I just go on plotting the graph starting with 2a also, if I just try to plot the same graph, y is equals to a, so now it becomes one more line, it goes on repeating, right? So this graph also repeats itself. So the cycle goes on repeating itself in this way. So the same graph goes on repeating. So this is how you can sketch the graph for f of t is equals to t and f of t is equals to 2a minus of t. So once you have plotted the graph, now we need to find out the Laplace transform. So if you try to observe the period over here, so period is given. If you go back to the question and check the period t in this case is 2a. So the period is 2a. So you can see the cycle also, it is 2a. For this particular period, the graph is being repeated. For every 2a period, the graph is replicating itself. The same thing it goes on. So it completes the cycle with period 2a. So we got t to be equals to 2a, therefore your Laplace transform L of f of t will be equals to, it is 1 by 1 minus e power of minus of st, it is integral 0 to t e power of minus of st f of t into dt. So if you try to rewrite this one, I will be getting the value to be equals to 1 by 1 minus e power of minus t value is 2a, so 2a, yes, I'll be getting integral of 0 to t value is 2a, it is e power of minus of st f of t into dt. Or further, if I try to split the integrals for the interval that is given in the question, so I can rewrite this as 1 by 1 minus e power of minus of 2a, yes. So the first limit is given as 0 to a, so it is 0 to a e power of minus of st. For 0 to a, check what is the value of f of t. F of t value is t times of dt, plus the second interval that is given in the question is a to 2a e power of minus of st. Check in the question for a to 2a, what is the value of f of t given? F of t value given is 2a minus of t into dt. So under the integral, because you are having product, so I'll use the Bernoulli's rule over here. So let us try to use the Bernoulli's rule. So if you use the Bernoulli's rule in this case, this will be acting as your u value, this will be acting as your v value. So u into v1. So u value is t, u value is t into v1. It is e power of minus st divided by minus of s, u into v1 minus u dash. Differentiation of t with respect to t will be 1. So minus 1 by s is a constant outside. Integration of e power of minus st will be e power of minus st divided by minus of s. So just use the Bernoulli's rule and evaluated the first integral. Limit values for t will be 0 to a. Coming to the next term, plus here this 2a minus of t will be acting as your u value, this will be acting as your v value. So once again we'll try to use the Bernoulli's rule. So it is u value, so 2a minus of t into v1, it is e power of minus st, you have to integrate it, e power of minus st by minus of s, minus of differentiation of 2a is 0 minus differentiation of t with respect to t will be 1 into minus 1 by s is constant, integration of e power of minus st will be e power of minus st divided by minus of s. So that completes the integration. Limit values are t is equals to a to 2a. Now we need to apply the upper and lower limit values. So if you try to simplify this expression, this will be equals to 1 by 1 minus e power of minus of 2a s. So minus 1 by s is constant outside, apply the upper limit value for t as a. So a e power of t value is a, so minus of as, that is upper limit value, minus the lower limit value for t will be 0 over here. So lower limit value will become 0. That is the first term. Moving on to the second term, there are 3 negative signs. So we'll just be getting negative of 1 by s into s will be s square. Upper limit value will be e power of minus, t value will be a, so as, minus the lower limit value for t will be 0. So that is your limit values for the second term. Now moving on to the next set of values. So here you have minus 1 by s as common outside, apply the upper limit values. So it is 2a minus t value will be 2a. So upper limit value, however, this will become 0 itself. So I'll just try to rewrite it 2a, yes, upper limit value, minus the lower limit value will be 2a minus of a into, it is e power of minus of as, lower limit value. So upper limit and lower limit is complete for this term. Move on to the next one. How many negative values are there? Minus of, minus of, minus of, this minus. 4 times minus is there, therefore it becomes positive. I'll rewrite over here. Plus, the common value is s square, 1 by s square. Now apply the upper and lower limit value for e power of minus st. So e power of minus of 2a, yes, that is upper limit value. Lower limit value will be e power of minus a, yes. So let us further try to simplify this expression. You have 1 by 1 minus e power of minus of 2a, yes. So just open the brackets and simplify completely. So that becomes minus a e power of minus of as divided by s. You can just ignore 0 there. So it is minus e power of minus as by s square. Next term minus of minus will be plus. E power of 0 will be 1. So 1 by s square. This term 2a minus of 2a, this term will become equals to 0. So just you can ignore that one. Next term will be minus of minus will be plus. 2a minus a will be a e power of minus of as divided by s. Coming to the next term in the next line that you have plus e power of minus of 2a s divided by s square. Then plus into minus will be minus e power of minus of as divided by s square. Further, let us try to simplify this expression over here. So this will be equals to 1 by 1 minus e power of minus of 2a s. We can see this negative term and this positive term will cancel out. Remaining terms will try to simplify. So s square is the LCM over here. You can just take s square as the LCM and write down the terms. So I'll first write this term, positive value 1. Next term you have this expression over here, minus e power of minus as minus e power of minus as will be minus 2 times of e power of minus of as. Next term is which is left out is e power of minus of 2a, yes, that's all you have. Alright, just close the bracket. So once again this expression is similar to a minus of b whole square. So this is a square, right, minus 2 times of a into b value. B value is minus of as plus b square. B square is e power of minus as whole square. So e power of minus a whole square is nothing but your e power of minus 2as itself. If you multiply inside, which is nothing but a minus of b. B value in this case is e power of minus as whole square. So it is a minus of b whole square will be getting. So if I try to rewrite this expression, it is 1 by 1 minus e power of minus of 2a, yes, and here you have got the expression as 1 minus e power of minus of as whole square divided by you have s square. Now this denominator value is in the form of a square minus of b square. Therefore I can rewrite this expression to be equals to 1 by, so is it not 1 minus e power of minus of 2as is in the form of a square minus e power of minus as whole square form. It is in the form of a square minus b square, which can be written as a minus of b into a plus b form. A minus of b into a plus b. So if you rewrite it is 1 minus e power of minus of as into it is 1 plus e power of minus of as. So here you have 1 minus e power of minus of as whole square divided by s square. So you can cancel out this term. 1 minus e power of minus as will cancel out once over here. You will be left out with 1 minus e power of minus of as divided by 1 plus e power of minus of as along with this s square value in the denominator. So once again you have to get in the standard form. Therefore we will try to multiply and divide by e power of as by 2. So multiply and divide by e power of as by 2. So if you multiply and divide, you will be getting the expression to be equals to, this becomes e power of as by 2 minus e power of. So if you multiply, that is nothing but your half minus 1. So half minus 1 will be minus half. So e power of minus as by 2 will be getting, because you are writing this as as by 2 minus of as. So that is plus half here, and this is minus of 1, which will be minus half. So it is minus half times of as value, which is minus as by 2, whole divided by denominator. Also the same thing you can do. It is e power of as by 2. It is plus e power of minus as by 2, and this a square will remain as it is. So this is nothing but it is 2 times of sine h as by 2. 2 sine as by 2 whole divided by this a square as it is, times of, this is 2 times of cos h as by 2. So however, this 2 and this 2 will get cancelled. Sine by cos will be tan. So it is 1 by a square as it is. So we will be getting tan h as by 2, which is the required solution. That's all I have for today. Thank you.